Okay, so this time let's talk about row equivalence. Row equivalence has sets of rules that you can use to solve system of equation. So basically, it will point us to system of equation, which will be our later topic after row equivalence. To give you a complete picture of what a row equivalence is, let's have some example. So let's say you're given this system of equation. So let's say this is the system of equation. Now, when we apply a row equivalence on this system of equation, the first step that we have to do is to transform these equations into augmented matrix. So what is the augmented matrix? Augmented matrix meaning we'll just copy everything here and then put those numbers inside of braces. Okay, so let's do that. So we have 3, let's just copy 3 here. We have 1, x contains a invisible 1, same with this, 1, y, same with y, it has an invisible 1, 1, and then 3, and then we have 2, 2 and 2, and then we have to separate those equal sign and then just copy those numbers. And then put this inside of square braces. So this is now what we call the augmented matrix. Okay. So now we have the augmented matrix, we can now apply row equivalence to this augmented matrix. How can we apply row equivalence? So we can only apply row equivalence if we know the rules for row equivalence. Okay, so what are the rules for row equivalence? Okay, so let me erase this first. Okay, so I'm going to create a separation here, and then we will write here the rules for row equivalence. So these are the legal operation. Of row equivalence. So number 1, we can interchange rows. So when we say interchange rows, the first row can be placed in the second row, and the second row can be placed in replace to the first row. So that is the meaning of interchange rows. Number 2, we can multiply a constant or a row by a constant. So meaning these rows here, let's say the first row, we can think of a constant wherein we can use that constant to multiply in each element on this row. Okay, that is a valid operation for row equivalence. And then the last rule is we can add one row to another row. So what we mean by we can add one row to another row. So let's say we can add 3 and 1, 1 and 3, 2 and 2, 31 and 25. So we can do that. That is the meaning of this rule. Add one row to another. Okay, so what I want you to do now is to copy these legal operations for row equivalence and then use that as your basis to solve system of equation. Because right now we don't have enough space to use to solve this given here. That is why for this moment I'm going to erase this first. Okay. Okay, so let's just pretend that we have already solved the row equivalence for this system of equation. So let's just assume that we have already applied row equivalence for this augmented matrix. So let's say after applying row equivalence, it turned out that this matrix becomes, let's say, I haven't gave you the procedure on how to do the row equivalence, but just to give you the complete picture of what will happen to the system of equation after applying row equivalence, just bear with me and assume that we have already applied row equivalence on this augmented matrix. And after doing that, it turns out to have this result. Okay, so once we have this result, this is now what we call from augmented matrix, this is now the result of row equivalence. And now, since we already have the row equivalence, we can now rewrite this and transform it back to system of equation. Okay, so we can start now solving for the last row because we already know that at the last row, our z is equals to 4. Remember, this is our x on this given. The first columns are all x, the second column are all y's, and the third column are all z. So this is x, this is y, and this is z. And x is 0, y is 0 here, and then z is 1, so z is equals to 4. So therefore we already know that z is 4. Okay? So now we can solve for our x and y. So let's solve for x and y. Okay? Let's start with y. Okay, let's start with y. So because there are too many given for x. So let's start for y, solve for y. We can do that by stating that y here plus 3 equals to 9. Okay, and then we already know that z is 4, so we can substitute 4 in place of z. So we can write this y 3 times 4 equals 9. And then this becomes y plus 12 equals 9. And then this becomes y equals to 9 minus 12. And y becomes negative, y becomes negative 3. So this is not the answer. Okay, so we were able to get y. Okay, now maybe this is the question that runs on your mind. Why did I start from z and then go to y and then last for x? The reason why we go for c, because c is the easiest row to solve, because it is already given here that z is equals to 4. So we have now the value for c. And then we go for y because that is the second easiest row to solve, because the given here is already almost simplified. So that is why we solve for y. and we made x as the last row to solve because it has so many variables involved, which are very much related to the z and y. So that is why we have to go first solving for z, then y, and then the last one is the x. Okay, so we can write down here now that our y is negative 3. Okay, so pause the video and then copy the details so that you have a guide on how to solve from augmented matrix going into system of equation. So now for the last part, we will now solve x. Okay, so let's erase this. So at this point, we were able to get the value of z and the value of y. What is left here, the missing variable is x. Okay, so let's start solving for y. So the first thing that we have to do is to write the equation for y. So this is the row that we have to get. So let's write it down here. X and then positive 2, that is plus 2y, and then minus 5z equals to negative 19. And then let's do the substitution. We already know the value for y, so let's write this. 2 times negative 3 minus 5 times, what is the value of z? 4. So let's write here 4 equals to negative 19. Okay, so let's fix this one. So x plus 2 times negative 3 minus 5 and then times 4 equals to negative 19. Okay, so let's now do the simplification. X positive 2 times negative 3, this becomes negative 6, and then negative 5 times 4, this becomes negative 20, equals negative 19. And then we have to isolate 6 and 20, so this becomes x equals negative 19 plus 6 plus 20. So this becomes x equals to negative 19 plus 6. This becomes negative 13 plus 20. And this becomes 7, positive 7. So x is positive 7. There you go. So negative 13 plus 20 equals 7. So we were able to get the value of x. So x is 7. So with this example that I gave you, we were able to create the big picture of system equation applying row equivalence, and then from the result of row equivalence we transform that into system of equation again, and then we solve for the variables that are missing, and those are the x, y, and z. And that's all for this video, and then see you in the next lectures.